Okay, so last week we were talking about vertical circular motion, which is going to be like half of the questions on your West Ed assignment is going to be about loops and circular motion and stuff. So remember that our general rule for vertical circular motion was that centripetal force is forces in minus forces out. Okay, so essentially we need to draw a free body diagram of the position in the loop that we're located on, and we only dealt with three: bottom on the inside, top on the inside, top on the outside. Okay, those are the three locations, and then calculating some various things, okay, about those spots. So I want you guys to try this question here. It's a little bit trickier, okay, but still within the realm of what we've been talking about. I want you to think about what apparent weight means. Okay, what force do you actually feel versus what force is actually present? Okay, that kind of thing. All right, so I'll give you guys a few minutes to work on this one and see how you do there. All right, so the wording of this one is what's kind of tricky about it. Okay, so they're telling us that we're looking for how fast the roller coaster is going. So we're looking for V. Okay, and we're told that it's a 35-meter loop, so we have R. And we know that they feel 2 times heavier than normal at the bottom of the loop. All right, so I'm dealing with this position here. Okay, what are the forces here? Gravity and normal force, right? So gravity is acting out of the circle. Okay, normal force is acting into the circle. Which force are they telling me in this question? Yeah, they're telling me the normal force. I can calculate gravity, but they're telling me the normal force is 2 times heavier than normal. What's normal? Gravity, right? So if I'm looking at this, Fn is 2 times what I would normally feel, 2Fg. Everyone with me on that? Okay, so when I plug this in, okay, yes, I've got normal force as my force in, gravity is my force out. Well, what that means is that Fn is 2 times Fg, or 2 mg, minus mg. What's 2 mg minus mg? Mg, right, 2 apples minus 1 apple is 1 apple. Okay, that's what we're looking at here. Okay, so what we've got then is, I don't know why that's still on there. That's a spoiler right there. Okay, so we got mv squared over r equals 2mg minus mg, which we said is just then going to be mg. Okay, and now I'm manipulating for v, so I'm going to multiply both sides by r, okay, and then divide both sides by m, which makes it cancel, and I'm back to the square root of grr. Man, that happens a lot. Because the question told me I felt 2 times heavier than normal. I normally feel 1 mg, right? That would be the normal force under normal conditions. Since it said 2 times that, I just went 2 mg. Yeah, follow me on that? Okay. All right, so now I just solve for v. Okay, so that's going to be 9.81 times 35. All right, so we're looking at 18.5. Actually, I think we only have 2 significant figures here, so it'll be 19 meters per second.
In the question, it says like a 35-meter loop.
Yep.
Doesn't that kind of sound like circumference?
Okay, so yeah, you're right. In terms of wording, if a physics question ever says it's a loop this big, they're giving you the radius. Okay, because we default everything about a loop to radius. If it's saying circumference, it'll outright say the circumference of the loop is this much, or the diameter of the loop is this. If it's giving you anything other than radius, it'll be stated. If it's not stated, it's radius. Yeah. Okay. All right. Does that sort of make sense, that one? Like the math of that's pretty easy. Okay. It's getting to the math from the question, right? That 2 mg thing kind of throws you off a little bit. All right. Try this one. We're looking for the apparent weight, which is which force? Normal force, right? Okay. We're looking for the apparent weight of a 75 kilogram person as they travel over the top of a 150 meter circle. So if we're traveling over the top, we're on the outside of the loop, okay, going over the top. All right, so looking for their apparent weight. Give you a few minutes on that one. All right, so what we have here is radius, 150 meters, okay? We have speed, 22 meters per second, and we have mass, 75 kilograms. All right, the situation we're in is that gravity is pulling into the circle while normal force is pushing out of the circle, and that's what we're looking for because that's what apparent weight is. So we're trying to solve for normal force. Since it is a vertical circle, Fc will equal forces in, okay, Fg minus forces out, normal force. Now, I don't want to solve for normal force in this situation because it'll come out what? It'll come out negative. So what I'm going to do is add it over here and then subtract Fc. Okay, so I'm going to end up with normal force equals force of gravity minus the centripetal force. Okay, and then when I plug in my numbers, that's going to look like this. Okay, so that's our answer there, but we'll have a look at it in here in just a second. So we've got normal force will equal mv squared over r, sorry, mg minus mv squared over r. Okay, so when we plug in our numbers, that'll be 75 times 9.81 minus 75 times 22 squared divided by 150. All right, so 75 times 9.81, okay, and then minus 75 times 22 squared. I forgot a bracket. Divided by 150. Not 15, 150. Oh, what did I mess up? Oh yeah, I had too many brackets. Silly. That's better. Okay. 4.9 times 10 to the 2 meters. Meters per second, sorry, newtons, not meters, newtons, because it's a force, okay? So this person feels a little lighter than normal. Is that kind of logical? Yeah, okay, it is logical. They should feel a little lighter than normal going over the top of a vertical circle. Okay, we saw how that worked, okay, last week. All right, questions on that one? That's a very typical vertical circular motion question. Hunter, question? No. All right, try this one. We're looking for how big the circle is. That means we're looking for the radius. Okay, so we're trying to solve for the radius in this one. So once again, we've got a situation where we're flying over the top of a vertical circle, except this time it says we're giving a feeling of apparent weightlessness. So I got gravity acting in. Do I have anything acting out in this situation? No, it says I'm apparently weightless. That means Fn is 0. Okay, so I'm back to Fc equals forces in, Fg minus forces out. There aren't any. So I really just have mv squared over r equals m times g, and I'm looking for how big the circle is. So I'm trying to solve for r. So I'm going to bring r over here and divide both sides by mg. Okay, so I'm just going to have v squared over g, okay, as my formula here. Equals r, so that's going to be 210 squared divided by 9.81. All right, so we're looking at a radius of 4.5 times 10 to the 3. Actually, 4.5, we have 3 significant figures there, 4.50. All right, so it's a circle with a radius of 4.5 kilometers. Okay, that may seem really big, but it's actually not unreasonable for doing what we're doing there. All right, are these vertical circular motion questions making some sense? Okay. All right, so I'm going to have you work on a couple more here just so we make sure we get the hang, because what do you suppose tomorrow's quiz will be on? Vertical circular motion, yeah. Okay, so in the workbook, going to be looking at. Okay, so starting at the bottom of page 2 and going on to page 3 here are the vertical circular motion questions. Okay, give those a try. They all pretty much work the same, which is why we don't need to spend a lot of time on them. They're all FC is forces in minus forces out kind of questions. Okay, so we'll give you some time on those and go over any ones that we need to go over. Okay.